Hey there, this is Dr. Rishi from the Learners Academy. Today we are going to discuss the second identity that we study in trigonometry. This is the tan and sec identity. Yesterday we talked about the sine and cos identity, that is sin square theta plus cos square theta is equal to 1. Today we are going to learn a similar identity and it is dealing with tan and sec. So without losing any time, let us have a brief revision of what we have studied so far. We have studied the 6 trigonometric ratios, that is sine, cos, tan, cot, sec, cosec. We have studied their complementary angles and how these ratios would work if we talk about the complementary angles. We also saw the values that these ratios would take at specific angles. Now we are going to talk about we have also started with the theoretical part wherein we study identities. We are already done with the first identity and today the second identity. So without losing any time, let us have a triangle ABC like this, which is having angle 90 degrees at P. I will call angle A as theta. Then from this angle we can say that AB square plus BC square is equal to AC square. Now for all the three identities, we are going to start with the same old Pythagoras theorem and then we are going to modify it to give us the final answer. So we have AB square plus BC square is equal to AC square. Now yesterday we divided both the sides by AC square. Today we want to find tan. Tan is opposite side upon adjacent side. So the adjacent side, that is AB, is going to be on the denominator side. So we will say dividing both sides by AB square we get. So it would be AB square divided by AB square plus BC square divided by AB square is equal to AC square divided by AB square. We can also write it as 1, same quantities dividing each other, plus BC upon AB square is equal to AC upon AB square. Now BC upon AB is our tan theta, so we can write 1 plus tan theta, tan square theta is equal to sec square theta. This gives us the second identity that we were talking about. Now let us go ahead and just like the sine cos identity, we will modify and manipulate this identity to get various ratios, various forms of the same identity. Let us go ahead and see various forms of the second identity, that is 1 plus tan square theta is equal to sec square theta. Now I can take this tan on the other side and I can say sec square theta minus tan square theta is equal to 1. So this is one form, it is used quite often. We can also write it as sec theta minus tan theta multiplied by sec theta plus tan theta, and we can equate it to 1. We can further write sec theta minus tan theta is equal to 1 by sec theta plus tan theta. This is one of the most useful identities because we can actually we have some questions which use this identity directly. We can also write sec theta plus tan theta is equal to 1 upon sec theta minus tan theta. Also further we can write tan square theta is equal to sec square theta minus 1 or tan theta is equal to root of sec square theta minus 1. We can also write tan theta multiplied by tan theta is equal to sec theta is equal to sec theta minus 1 times sec theta plus 1, giving us tan theta divided by sec theta minus 1 is equal to sec theta plus 1 upon tan theta. So these are various manipulations that we have. We can directly have one more manipulation, that is sec theta is equal to root of 1 plus tan square theta. Now these can be readily replaced with each other and we can get the final answers directly using these manipulations. Now let us go ahead and talk about a question from 10th ICSE maths book. This is solved example 5 sub question 2. The question is as follows: tan A plus sec A minus 1 upon tan A minus sec A plus 1 is equal to 1 plus sin A upon cos A. We have to prove this. So let us see how we can do it. So now in this equation, what we have in this particular example, what we have is we have tan A plus sec A minus 1 upon tan A minus sec A plus 1 on one side. Now this is a slightly tricky question because on one side we have a trinomial or a equation which has 3 different parts to it, and on the RHS we have an equation which has only 2 parts and a single part. Okay, so let us go ahead and see how we can solve this. Yesterday, while talking about the sin cos identity, we said that cos square, it is important to know when to use cos square theta plus sin square theta is equal to 1 and when to replace 1 by that cos square theta plus sin square theta. So as we are discussing, it is important to know when to use 1 in replacement of the trigonometric ratios. This is one such a question. So this 1 here and this 1 here can be replaced by sec square theta minus tan square theta. So I can write it as, my LHS can be written as tan A plus sec A minus sec square A minus tan square A. So I have replaced this 1 by my identity. Now I will not be doing the same with the denominator. Why? You'll see it in the later part. Now we are going to do a very smart trick here. We are going to write, instead of writing tan A plus sec A, we are going to write sec A plus tan A minus, now this I can open up as sec A plus tan A multiplied by sec A minus tan A, and the whole thing divided by tan A minus sec A plus 1. What would it give me? So I have sec A plus tan A is common in both of them, so I can write it as sec A plus tan A is taken outside, and in the bracket, from this bracket I'll have only 1, and from this bracket I'll have minus sec A minus tan A. The whole thing divided by tan A minus sec A plus 1. Now this can easily be written as, and I will rearrange these terms. So I'll get 1 minus sec A plus tan A divided by tan A minus sec A plus 1. Now I can further rearrange the numerator as tan A. So I've written tan A first, then minus sec A, I've kept it as it is, plus 1, and you'll see that it's equal to the denominator. So I can cancel this and this as they are same, giving me my final answer as sec A plus tan A. But my sec A is 1 upon cos A and my tan A is sin A upon cos A, giving me 1 plus sin A upon cos A. Yeah, giving me the right hand side. So this would be equal to my RHS, and we are pretty much done with solving this sum. Now these kind of examples are quite crucial because they carry quite a bit of marks. These kind of examples carry approximately 3 to 4 marks in ICSE, and they are also seen in CBSE and State Board exams. There is also an alternative method of solving this example. If any one of you knows it, please go ahead and post it in the comments. Along with your post, you shall also post your name, your standard, and your school name. And you would also be eligible for getting a free gift from us. To inquire about the giveaways for the winner, please contact us on the numbers given in the description. We will guide you further regarding the giveaway and how you can avail it. Now, let us take this example from CBSE NCERT book. This is example number 15 in the old version of the book. It is prove that sin theta minus cos theta plus 1 upon sin theta plus cos theta minus 1 is equal to 1 upon sec theta minus tan theta. Now, what we have here is we have sin theta minus cos theta plus 1 upon sin theta plus cos theta minus 1. And on the other side we have 1 upon sec theta minus tan theta. Now, it is clearly evident that we would have to convert the sines and coses on my left hand side into tans and secs. We are going to use this very identity that is there to solve this kind of sum. Now, I have chosen this particular sum because many of my students find it really doubtful to solve a sum which has 3 parts on one side and 2 parts on the other side, because it's slightly complicated to cancel out what we'd say a trigonometric equation which has 3 parts to it. So now let's see what we will be doing. First thing we need to do is convert these into sec and tan. The easiest way to do it is to divide it by cos theta. So I can say LHS is equal to sin theta minus cos theta plus 1 upon sin theta plus cos theta minus 1. Then I say dividing by cos theta, we get, now what are we dividing? We are dividing the numerator and the denominator by cos theta. Since we are dividing the numerator and the denominator by the same entity, the value doesn't change. So we have sin theta upon cos theta minus cos theta upon cos theta plus 1 upon cos theta. The whole thing divided by sin theta upon cos theta plus cos theta upon cos theta plus minus 1 upon cos theta, giving me tan theta minus 1 plus sec theta upon tan theta plus 1 minus sec theta. Now I can rearrange them in a very specific manner, and get the final answer as so I can write tan theta plus sec theta minus 1 divided by tan theta minus sec theta plus 1. Now we have to make sure that we are cancelling things out. However, when we are cancelling these things, there needs to be a unit of 3 that is to be cancelled. So let us see what we get. We have so if I multiply tan theta, now I cannot cancel them out readily, so I will have to multiply the numerator and the denominator by some entity so that I would get common terms in such a way that I can cancel them out. So I am going to take tan theta plus sec theta minus 1 and I am going to multiply it out by tan theta minus sec theta. And the denominator also I do the same thing, tan theta minus sec theta plus 1 and it gets multiplied by tan theta minus sec theta. Now this is a relief because this is what I want to prove. So I can write it as, now this gets multiplied by this, I would get tan square theta minus sec square theta minus tan theta minus sec theta divided by tan theta minus sec theta plus 1 times tan theta minus sec theta. Now, what is this tan square theta minus sec square theta? From this identity gives me 1 is equal to sec square theta minus tan square theta. However, here I have tan square theta minus sec square theta, so I have to write it in the opposite order. If I write subtraction in opposite order, on the other side I need to change the sign. So this here will become minus 1. So I have minus 1 minus tan theta minus sec theta, the whole thing divided by tan theta minus sec theta plus 1 times tan theta minus sec theta. Now let us open up this bracket and see what we get. So if I take minus 1 outside, I can write 1 plus tan theta minus sec theta divided by tan theta minus sec theta plus 1 times tan theta minus sec theta. Now if you see, this quantity and this quantity are exactly the same but in a different order, so we can cancel them out, giving us minus 1 upon tan theta minus sec theta, or we will get 1 upon sec theta minus tan theta, which is equal to our RHS. So this is a slightly lengthy example. However, it is quite interesting because it does use the fact that 1 is equal to sec square theta minus tan square theta. Now, this is a slightly different example from 10th State Board, which uses numerical values and the identity. So I find it really interesting. So I am putting this in. If sec theta is equal to 5 upon 7, then find the value of tan theta. So here we are saying sec theta is equal to 25 upon 7 and we have to find the value of tan theta. Prior to this, we used to draw the triangle and then find sine, cos, and then go ahead and then actually find the value. However, we can directly find the value of tan theta using the identity. So the identity is 1 plus tan theta, 1 plus tan square theta is equal to sec square theta. So effectively, you can say that tan square theta is equal to sec square theta minus 1. Here sec theta is 25 upon 7, so I can write 25 upon 7 square minus 1. So that would be 625 upon 7 minus 625 upon 49 minus 1. So that is 625 minus 49 upon 49. So this would be equal to 576 upon 49. So this would be equal to 576 upon 49. So it would be 576 upon 49. Now I need to find the value of tan theta. So value of tan theta would be root of 576 upon 49. So that is 24 upon 7. 24 upon 7. And this is how we are going to use this trigonometric identity in a slightly non-traditional way to find the values of other angles as well. That would be it from my end for the day. Please like our videos and share and subscribe our channel. There are a lot of students who need this help, and we are always ready to help. In case you have any queries, drop your queries in the comment section. You can always drop in at the Learners Academy, where we are always ready to help you with your studies. This was Dr. Rishi from the Learners Academy. Thank you.